A very important problem of complex number, and the problem is so that the sum of square of all values of this is equal to 0. It problem may be in the form of MCQ, okay, and very easily the options are given here like 0, 1, minus 1, I, minus I. Okay, so it problem may be of MCQ type or may be of long type. Here, to solve this problem, we use three simple results of complex number. The first result is generalization of complex number. We already know about this. Second result is very important theorem of complex number. This is De Moivre's theorem. This can be used here. And the third result is the sum of GP series. Okay, we already write these three results. Now we first consider root 3 plus I whole to the power 3. Okay, and to form it in polar form, we first divide it by 2. That is root 3 by 2 plus I into half whole cube. That is, we have to write here 2 to the power 3, right? And it is clear that 2 to the power 3 into, this can be written as cos pi by 6 plus I sin pi by 6 whole cube. Okay, and using De Moivre's theorem, we get the result 2 to the power 3 into cos pi by 2 plus I sin pi by 2. Okay, now generalizing this complex number as 2 to the power 3 into cos of 2 n pi plus pi by 2 plus I sin 2 n pi plus pi by 2. Okay, and we write here n, this is belongs to z, that is n may be one of integer. Okay, now taking the term as root 3 plus I whole to the power 3 by 7 as given in our problem. So this is equal to 2 to the power 3 by 7 into this complex number cos 2 n pi plus pi by 2, or it may be written in the form as this can be written as 4n plus 1 into pi by 2 plus I sin 4n plus 1 into pi by 2 whole to the power 1 by 7. Okay, and now using De Moivre's theorem, we get 2 to the power 3 by 7 into, this is cos 4n plus 1 into pi by 14, okay, plus I sin 4n plus 1 into pi by 14, and we must write here n, this is equal to 0, 1, 2, 3, 4, 5 and 6, because we get 7 value of this term. Because if we take any complex number z, then z to the power 1 by 7, that is 7th root complex number, that is this 7 complex number can be written in the form as 2 to the power 3 by 7 into e to the power I into 4n plus 1 into pi by 14, where n is as 0, 1 to 6. Okay, and we know that e to the power I theta, this is equal to cos theta plus I sin theta, and this is the Euler form of complex number. Okay, if we use Euler form of complex number, then to calculate any calculation of complex number very easily. Okay, so we use here the Euler form of complex number. Now we have to find the sum of the square of all values, that is sum of the square of all 7 values. So we get sum of square of all 7 values as, this is written as summation this is n equal to 0 to 6, and the sum of the square is 2 to the power 6 by 7, because 2 to the power 3 by 7 whole square, and by taking the square we get e to the power I into 4n plus 1 into pi by 7. Okay, and if we write it in the expanded form, then it is clear that 2 to the power 6 by 7, we take common this, and the first term by putting n equal to 0 we get e to the power I pi by 7, and the second term is given by e to the power I into this is 5 pi by 7 and so on. Okay, and clearly this is a geometric progression with first term is this, and the common ratio r is given by e to the power I into 5 pi by 7 by e to the power I into pi by 7, that is e to the power I into 4 pi by 7. So using this result, the sum is given by this is 2 to the power 6 by 7 into a means the first term, this is e to the power I into pi by 7 into 1 minus this is the common ratio r, and we get e to the power I into 4 pi by 7 whole to the power 7, because 7 turns in this series by 1 minus e to the power I into 4 pi by 7. Okay, so we get 2 to the power 6 by 7 into e to the power I into pi by 4 this term, and this is 1 minus e to the power 4 pi I by 1 minus e to the power 4 pi I by 7. Now the value of e to the power 4 pi I, what is the value of e to the power 4 pi I? E to the power 4 pi I is given by putting the value of theta is equal to 4 pi. So we get this is cos 4 pi plus I sin 4 pi. So clearly this is 1 plus I into 0, this is 1. So we put the value of this is equal to 1, we get the result is 0. Okay, so we prove that the sum of the square of all values of this, that is the 7 values of this, is equal to 0. This is the complete proof of this problem. Very important and interesting problem of complex number. Thank you for watching.